Hello students, welcome to Young Cubs. Today we are doing Electricity Lecture 3. Till now children, we have learnt about the different types of electricity, which is static electricity and dynamic electricity. We've learnt how electricity comes from the word electron and how electrons jump in a loop. Then we've also learnt about the different definitions. We've also learned about the basic formulas, and today we are going to talk about the transmission of electricity from the power generating power plant to the consumers. So let's start. So this, children, do you see this? Okay, this is the power plant. All right. So this is where electricity is generated. And how much is generated? It is around 11 kilovolts of electricity which is generated here. From here, through cables and heavy wires, electricity is transferred or transmitted to step-up power transformers. So what happens at these step-up power plants? Okay, here this 11 kilovolts electricity is raised to 132 kilovolts. It is raised. The electricity is raised over here. Then via wires and cables. Okay, these are known as pylons. Okay, then via wires. These pylons have to be really tall so that these cables and wires don't come in contact with any living being. They try that these pylons don't come in contact, the wires or cables on these pylons don't come in contact with birds as well. But they try their level best, yet you may see some bird dying, trying to sit on these wires. They kind of die. That's the amount of electricity generated out here and transferred. So via these cables, okay, then the electricity from the step-up power plant, okay, is transferred to the transmission substation. How much is the electricity that has been raised up to? It is raised up to 132 kilovolts. Okay, now from 132 kilovolts, again, by the time they send it here, the electricity from 132 kilovolts is reduced to 33 kilovolts. Again, it is reduced. Okay, so first 11 kilovolts raised to 132 kilovolts, now reduced to 33 kilovolts. Now, from here, again through wires and cables, okay, electricity is transmitted, okay, to distribution substations. Okay, this is the distribution substation. Okay, till now electricity is yet at 33 kilovolts. Okay, but when they transform by 33 kilovolts, the electricity, by the time it reaches, or it is reduced and sent. Okay, and here only 11 kilovolts of electricity. It's further over here. From 33 kilovolts, electricity is further reduced to 11 kilovolts, where from here, from the distribution substation, as the name suggests, electricity goes to commercial units and to domestic units. After, from 11 kilovolts, it reduces the electricity to 220 volts. The kilowatt is gone. Okay, only 220 volts is sufficient enough for domestic consumption and commercial consumption. All right, children. So that, imagine, children, from 220 volts of electricity, somebody can, if somebody comes in contact with direct electricity or live wires, that wire can kill, can come in contact with electricity. Only 220 volts can kill a person. How dangerous it is. Imagine 132 kilowatts and 11 kilowatts and 33 kilowatts. How dangerous can that be? And hence these, these plants, okay, these step up power plants and the power generation plants are placed really away from the populated areas. Okay, children, understood how the transmission of electricity happens from the power plant or from the the station, power station, to the consumers. Recap: 11 kilowatts, step up to 132 kilowatts, raised over here, then through cables given to transmission substations at 33 kilowatts, further reduced to 11 kilowatts at the distribution substation. From the distribution substation, when electricity leaves for commercial consumption and domestic consumption, it only gives out 220 kilowatts. Hope that much is clear. Now, children, when I say commercial consumption or domestic consumption, I do not mean they have yet reached our direct factories or industries, or they have reached our commercial places or our houses that we live in, our apartments that we live in. It's not yet reached there. Okay, there is still, it's a common center, a common place in the city where this electricity has yet been transferred. Okay, now to supply the electric power to a house from this common center, from this common city substation, either the overhead wires or cables on the poles, electricity is either transmitted through that, or there are underground cables, okay, which supply electricity to each building. Okay, now we need to learn a little about these wires, okay, these cables, these wires. Now they are color coded, children. Okay, the live wire, okay, the live wire is red in color. Okay, the live phase or the live wire is in red color. The neutral wire, okay, is either in the neutral wire is either in blue or black. Okay, and the earth wire, it is connected to the ground wire or earth wire, anything it can be called, is either green or yellow. So live wire also, children, can be either red or brown. Okay, anything. Neutral wire, as I said, will be either light blue or black. Okay, they're all color coded. Okay, and the earth wire will either be green or yellow. All right, understanding this much? Now, the neutral wire and the earth wire, okay, are connected together at the local substation so that the neutral and the earth wires are at the same potential. They have the same potential. Why are they connected at the local substation? For same potential. All right, and what is the potential? It is nothing but 0 volts. They cause no harm. And the live wire, okay, is how much? At 220 volts. We saw this, how it comes down to 220 volts. Okay, and it carries the current from the source to the distribution board. What is a distribution board? In the city substation, this electricity has to further be distributed all over the city, right? So it's and while they are at the distribution board, the neutral wire is for the return of the path of current. So that's the alternating current. Okay, and the earth wire passes the current to the earth. Children, did you know that electricity loves the earth? Okay, and once it always finds a pathway to reach the ground or reach the earth. If you become the pathway, you get a shock. So that you don't get a shock, you do not get an electric shock, this earthing wire is connected to the or to the ground or the earth. It is also known as the ground wire or the earthing wire. Okay, so here's a summary of the three cables or the three wires. So the live wire is red or brown. It carries 220 volts and it is used to carry current from source, that is the city substation, to the appliance in our house. Okay, the neutral wire is black or light blue. How much is the voltage? Simply 0 volts. It does not carry electric current in it, and it is to provide the return path for appliance to source. If it's not being used, let it go back. If you've turned on a mixer grinder, okay, electricity is passing through the plug or the socket to the mixer grinder. Now we are done. We switch off we switch off the plug. Okay, we remove unsocketed. We switch off the plug so that electricity does not stay in the wires. It goes back. The alternating path. It goes back to the substation. Okay, so it provides the return path from appliance to source. And the third one is earth or earth wire, or the ground wire. It is either green or yellow. It is the voltage it carries is again 0. Okay, and it is used to provide connection to the earth. All right, children, this much is clear. Now, children, remember, our electricity has just reached our city substation. Okay, now, from the city substation, this electricity gets connected to via cables from the poles to the meter in the house. Now, this meter, okay, this energy, this meter is first. So, from here, the wires and cables get connected. In the meanwhile, in your buildings, there will be a fuse box. Okay, this fuse box is put or attached by the company. It's a company fuse or a pole fuse. Okay, we cannot touch it. It is the company guy with the proper ID of the company. Only he is authorized to touch this company fuse. Alright, children. Now, after that, okay, the live wire is attached to the energy meter in our buildings. Children, we live in flats, in Mumbai or in any other city. We live in flats and apartments. There are tall buildings that we live in, and if at the bottom, there's a proper electric house where everybody's meter is separate, electric meter is separate. In the you must be entering your building, or there must be a proper powerhouse in your buildings where everybody's meter is separate. Okay, this is the electric meter. Okay, in this electric meter there is something called as an armature. Okay, so there's something called as an armature like this. This is the household meter or the electric meter, which is down, which is outside the house. The electric guy or the company guy will come, take the reading of this, and then he notes it down, and then they calculate your electricity bill, and then the electricity bill properly comes home. So this on the basis of this. Okay, so do you see this? this rotator kind of a thing, that's the armature. Now this is attached to 5 dials. Okay, I'll explain the function of the armature. But let's see, from the city station now, your electricity via the company fuse has reached the electric meter, which is down or outside your houses. Okay, from here, okay, the live wire gets connected to a main circuit or a main switch box inside your house. So every switchboard, okay, the wire from every switchboard in your houses, on the walls of your houses, has an internal connection, okay, to this main switchboard. This main switchboard will also have a main fuse, children. I will explain the meaning of fuse as well. What is a fuse and what is its function? And from this main switch box, okay, every live wire goes to these sockets, okay, on in the walls of your house. And from here, if this is for the bulb in your house, okay, you turn on the switch, the bulb turns on. For the fan turns on. For the AC turns on. All right, so there may be several in each, one in each room, so there may be several switchboards. Okay, now see how the connection moves. All right, children, this much is understood. Now, this electric meter is also known as the kilowatt hour meter. Okay, this is the one that actually generates, or it actually rotates the dialer, or the rotates, and we pay our electricity bill generated or shown over here. These days we have digital meters that have come up, but this is the traditional one. All right, children, so we have this armature out here, referred to as A. Okay, now these basically are attached to 5 dialers. Okay, now these dialers are similar to your place value table in maths. Units, tens, 100,000, 10,000, like that. So once the meter, this units start getting calculated, and this rotates, okay, once it rotates 99 times, okay, 9 times, not 99, 9 times, this one gets activated. Once it rotates, okay, 99 times, okay, this is showing 9 and this one is showing 9 times that it's rotated, okay, this one gets activated. Once it shows another 9 over here, so the how many units have been consumed? 999. Then this one 9 times, this one 9 times, and this is how. So technically, this is 99,999 is what can be displayed out here. Okay, as per this one. All right. So see the attachments as well out here. The armature is connected to a magnet. Okay, there's a disc. It rotates. It rotates the armature. Armature is connected to the various dials, and that generates, and it tells us how many units of electricity have we used. Okay, and then it is multiplied with the basic one per unit charge, and we get our electric bills. Children, look at this now. Okay, this one is the last month reading, and this one is this month reading. Okay, from this month, okay, what was the this month reading? 0, 8, 2. Look at the hand, look at the needle. It is, say, can I say it is around 9, and it is not yet reached 5, so I will still take this as 4. Alright? Okay. And this month's reading is 5. It's between 2 and 3. It is supposed to reach 3 but not yet. So I'll take it as 2. This is 6. Alright. This is, how much is this? It's 1. Okay. And this is 5. So I will take the reading as, so my old reading was, let me write it here, 49,280 units, and the newer reading was 51,625 units. I'm going to subtract 51,625 from 49,280. How much is that? Which is equal to, or I'll write it on this side, equal to, comes up to say 51,625, 49,000. So let me say units consumed are 2, 3, 4, 5. 5 minus 0 is 5. 8 minus 2. 8 minus 2 is 6. 280, yeah. 2 minus 8, sorry. 2 minus 8 is 6. 6 minus 2 is 4. Carry over. Okay, 9, 8, 3. Alright. Okay, children. So this is the electric consumption out here. Now this is multiplied by the per unit charge, which is 6.25. Alright. So when we multiply 2, 3, 4, 5 units by 6.25, the bill amount generated will be 14,656.25. Understood how every month it is calculated? Okay, the person or the person's job, the company ID holder will only come and take the reading each month and report it in their office, and then it is automatically multiplied by 6.25, or now it must have increased. Okay, and that's how the electricity bill is generated. Got it, children? Understood the working? So now, these days, this kind of a digital meter is being used, which gives us everything in detail automatically. All right, children. Then we come to the electric fuse. Children, electric fuse is a safety device. Okay. Now this has a porcelain holder. It has fuse wires. It is termed as F. It has terminal 1, terminal 2, and then there is a live wire which is passed. This is in the socket in your switchboards, in your main switchboard. Okay, there is this socket which is fixed on the board, and there are live wires which are connected out here. Okay, and this socket fits in right into these sockets, so that it can protect our house from short circuit. So basically the electric fuse is a device which is used to limit the current in an electric circuit. It safeguards the circuit and the appliances connected in the circuit from being damaged. They don't get burned, they don't get overloaded. Okay, now if the current in the circuit exceeds a specified value due to voltage fluctuations, okay, there could be a short circuit. Alright, so this is how the fuse works, the attachment of the fuse works. Alright, children. Now generally the fuse wire is made up of an alloy of tin, and fuse wire is made up of an alloy of tin and lead. Alright. how science is connected, how physics chem is connected to each other. All right. Now, what is the purpose of the fuse? If the insulation of the wire of the cable used in the wiring, okay, breaks. Okay, what happens? The live wire comes in contact with the neutral wire. Okay, and this can result into a short circuit. So the maximum current must be passing through these wires, and what happens is the wires can catch fire due to the excessive heat. So after a certain point, okay, what happens is these fuse wires, apparently, why do you call it fuse? Okay, it fuses, it melts, and that's how it prevents a short circuit from happening. So when this fuse wire melts, the circuit, apparently, there's a obviously everything has to move in a loop. So now this wire has melted, the circuit is being broken, and once the circuit is being broken, the circuit becomes incomplete. Okay, so once the circuit is incomplete, no more electricity can pass through in a loop. All right, so no current then flows, and the appliance in the circuit does not work. That is another thing, but the circuit is saved. Now, after removing the fault in the circuit or the appliance, a new small fuse wire, it's very small, children, a new fuse wire is fixed back into these terminals, into T1 and T2, okay, in the holder, and the circuit is complete again to make the electricity run again in the house. Nowadays, these domestic gadgets such as ovens, geysers, press, refrigerators, air conditioners, etc., they all are provided with a cartridge topper fuse in their live wire. All right, children. So, what are the characteristics of a fuse wire? Um, so a short wire with a low melting point that can be easily melted. Okay, it has a wire with a low melting point. The normal copper wire is not being attached to it. The copper wire melting point is around 1080 degrees Celsius. So you cannot have that high a wire in that, a wire with that high melting point. So you need a wire which has a low melting point. So it is made up of an alloy of lead and tin, and this alloy melts at barely 200 degrees Celsius. Okay, the wire is not allowed to heat, or the electricity that passes through the wires. Okay, it heats it up, and when the heat reaches around 200 degrees Celsius, it melts and the circuit is broken because the wire melts. Okay, so this is one of the properties where its melting point is taken into consideration. The fuse wire is connected in series with the live wire. Okay, its temperature rises much faster than the copper wire. As I said, the copper wire has a melting point of 1080 degrees Celsius. So it has to be way lower than that. Okay, and the thickness of the fuse wire depends on the current rating of it. Okay, so nowadays, okay, this fuse is very commonly available in markets. It's very easily available. Okay, now these days the MCBs are used. What is an MCB? Miniature circuit breaker. Alright, these are used commonly these days. So, what are MCBs? Okay, MCBs are nothing but miniature circuit breakers. Okay, so they are automatic switches. Okay, this is how it looks like. Really, we very commonly we call this as trip as well, children. Electricity gets tripped, in case if there is the wire gets heated. Okay, it automatically trips. So it is an automatic switch which trips if in case if it heats up, the wire heats up, the circuit heats up. It protects the household wiring from excessive flow of electric current in a circuit. the MCB automatically falls down. See, it moves down to break the circuit, and the entire house, imagine the electricity completely breaks. Okay, the circuit completely breaks. So then you need to go to your main switchboard and you need to put this strip up back again, and it resets. Electricity resumes, and after the fault is rectified. Okay, children, that's all for today. Thank you and God bless you all.